So to implement first num self-divisors, we need to create an array to return. So we can do that using int bracket bracket to declare an array. We're going to call it return array. And we have to also create the array. Don't forget that part. And we need it to be the size of num. And then we're going to need a loop. So we're going to have a while loop. And we're going to loop as long as a count. So we're going to keep track. We're going to need another variable at count. And we'll start that off at 0. And as long as count is less than num, we're going to continue our loop. So we haven't found enough self-divisors yet. We're also going to need to keep track of, we're going to start at this passed-in start value, but we're going to change it over time. So we're going to need to keep track of that. So we'll call it maybe current num, and we'll start that off at start. So as long as count is less than num, let's check if the current numbers, so if current num, and we need to use this other method is a self-divisor, so we're going to use that, while if self-divisor current num, if that returns true, then it is a self-divisor. So in that case, we want to add it to the array. So return array of, and what's index? Well, the count will work as our index of count. So that'll equal num. And then we need to increment our count to know that we've added one. And so if we do that, then if the while loop finishes, then we know that count is equal to num, so it's time to return the array. Don't forget to return things from your methods. So let's try this. That's compiling and running. Oh, we got an infinite loop. We forgot to increment the current number. So we also need to increment the current number. Num increment. So let's try that. And we get the correct response that for first num self-divisors of 10, 3, we need it to print 11, 12, 15. And I had another test if we started at 22 and 5, we get 22, 24, 33, 36, 44. So it seems to be working.